here's what I'm going to talk about, which is some ideas and some technology that me and my colleagues at Textile have been thinking about and starting to build. And so I think what I'm going to do today is talk a little bit about what originally motivated us to work on this stuff, where our kind of thoughts have arrived more recently, and a little bit about some of the tech that we're developing, and some bad jokes in between, and then we can maybe have a discussion or something like that at the end. I've kind of set it up so I can talk for a very long time or a short amount of time. So basically, if you're just sitting there and starting to nod off, I'll stop, and if you seem like you're nodding along, I will keep going, and we'll see where the night takes us. But yeah, kind of the idea here is, how can we start to think about a new model for, here I say a new model for an interoperable dweb. Some of these concepts probably could work just for any web, but we're going to focus I'm going to focus on a decentralized or mostly decentralized web, given that that's the name of the meetup that we're at. So first, a little bit about me. I am Carson. I was a university professor till pretty recently, and then I left that for the slightly meager salary of a startup technology company. And so, we'll find out if that was a terrible idea or not. But in the meantime, I get to work and play with a bunch of stuff that Textile works on. Specifically, we do a lot of stuff with IPFS, Interplanetary File System. How many people are at least somewhat familiar with IPFS? Okay, that's great. I'm going to assume that you all put your hands up. Well, no, I can elucidate on IPFS a little bit. And then decentralized web tech and ideas more broadly. And I left academia basically so that I could live and work from the West Coast. Because before that, I was living in Boulder, Colorado, which is beautiful and lovely and very nice, but it's very dry. So, it's much better when it rains all the time. So now I'm here on the West Coast. Okay, so I might have just skipped a slide. Let me just check. There we go. Oh, good. Okay. Excellent. We'll just edit this out of the internet part. Okay, so yeah, this is kind of what this is where the motivation for a lot of what I'm going to talk about and what Textile has been doing started from, right? Which is like, we'll take a bunch of personal data, put it on the internet, and see what happens. What could possibly go wrong? And we know from a lot of examples that stuff kind of has gone wrong. And I was a little bit worried I might be sort of preaching to the choir with some of this stuff, so I'll go pretty quickly. But the really early on sort of indication that maybe something was happening was, does anybody remember this? This example? Yeah. And I remember at the time, and I was very young at the time, thinking, wow, that's pretty crazy that they were able to figure out that this girl was pregnant for her dad. But then, she probably wasn't telling her dad at the time anyway. But it's an example of like collecting a certain type of and a certain amount of data and revealing a very narrow view on a particular individual. And it doesn't really reflect necessarily what this, much about this person, but it's this sort of digital effluence that they leave behind, their shopping behavior and things like that. And there's other examples of sort of apps collecting geographic data that you maybe didn't really think about. This is a really good Twitter thread if you want to follow it. I can make these slides available later too. Lots of examples of apps knowing where you were last night and scary ways to frame it. But chances are you're a normal person who was at a normal place last night. And so no big deal, don't worry about it. We'll just keep doing that. And you're like, oh, okay, yeah, okay. I get free email, so let's just do this. And then you start to collect other things, and then you find out that actually there's a whole industry of data brokers who just collect data about people, and they put them into nice packages and they sell them to other people, and they use that data and blah, 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 blah. And you start to build up an actual pretty realistic profile. And then with all the sort of scary browser tagging and blah, 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 you can get a profile of people, and then it's all scary. And depending on who you're talking to this to, they say, no, that's not how it works, and it's not dangerous. Or like, that's okay. I don't do anything weird, so don't worry about it. And so most people shrug it off, and that's probably fair. But there's lots of examples of, I don't want to rag on anyone in particular, but PayPal, they share your data with a lot of people if you use PayPal. And they're not, that's just one example that a company actually went and looked at them specifically, but basically everybody is using these data brokers. And there's good reasons for it. I don't know if people have read this article from Chris Dixon, Why Decentralization Matters. And he's got this pretty nice little curve, which basically sort of outlines a platform's relationship to users, and then their relationship to their complements, so like other developers, businesses, and things like that. And basically what ends up happening is your sort of incentives for how you work with your users starts to shift once you realize that, oh crap, my VC money's running out and I have to start making some money here if I want to keep paying everybody to do their jobs. And so you realize, it makes a lot of sense to just take all that really awesome data that I was collecting in order to make a better app for my users to make them happy. Well, I could just start selling it to third-party providers and things like that, and I can supplement my income or even make any money that way. And so example is Twitter. That's what they do, and it's pretty much their only monetization strategy, unless you paid for Twitter somehow. You didn't, so instead you're paying for it that way. And then we get things like this, which is fully legitimate, right? So a bunch of Facebook users weren't really expecting their profiles to be harvested and used for research and such, but it was a legitimate use. It wasn't a data breach. That was just how that relationship with users had changed. And then people are like, whoa, that's privacy stuff. That's scary. Except, no, people don't really care that much still. So here's a little graph from 2014 to 2018. And this is like Cambridge Analytica sort of scary thing. And actually, interest in privacy-related issues is continuing to go down. And partly I think it's just because it's like, oh, another data breach. Well, that's how the internet works, so it's okay. And we just keep going. And so, it actually, interest was up there, but now people don't worry about it too much. And, so when Textile first started, we were like, oh, yeah, we'll get people with the privacy angle. They'll get it. Everybody's going to get it. And they don't. Well, they get it. Everybody gets it. You all get it. But it's not that big of an issue, right? Because it's not really affecting you directly that much right now. And even if your data was breached in a data breach somehow, like nobody, reached into your pocket and took your data, you'd already put it there. It was away, right? So it's not an immediately scary thing. So, okay, that's not going to sell, whatever it is that we're making. But there are some very interesting related consequences to things like this that we can start to think a bit more about. And so one of the big things with platforms in a Web 2, standard web kind of framework is that when you have them, you start to collect a bunch of very useful data. And you get to the point where you start to benefit from network effects. And something some folks call, like Matt Turk here calls, data network effects. So basically, I don't know, is anyone familiar with the term network effect? It's pretty kind of buzzwordy, maybe not right now, but over the last couple of years it has been. But basically it's the idea that, actually I think I have a graph. Yeah, this is it, right? So the more users you get, the more data you can collect to build smarter, better things in the background, whatever it is that you're using to drive your technology, which leads to a better product, which leads to more users, blah, 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 blah. And you get this sort of compounding or feedback loop. And then now you started with something that was kind of cool that people liked, and now you've actually got a really useful thing which actually drives itself, right? So, Facebook is like the perfect example of a network effect. It also works great because it's a social network, so it's like double network sort of thing. Yeah, double network. So that's a good example, which is like the more people who use Facebook make Facebook better, blah, 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 blah. And The network effect by itself is just the more people who use it, the more people want to use it because their friends are using it, and blah, 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 blah. And then the data network effect is the more people use it, the more data they get, blah, blah, blah. So it's this kind of impressive machine that eats data and produces more, uses to produce more data, et cetera. So that happens, and you get what some people call data silos or data walled gardens, where now, if I'm an incumbent developer and I want to develop my new awesome idea, basically I'm going to have to play ball with some existing platforms that already have data network effects. Because there's no way that I'm going to be able to make something awesome enough and fast enough that I will be able to compete with those network effects. Or forget even just competing, just even existing, right? If I wanted to, have a chat app, like there's no, and my idea was so unique and awesome, and it was going to be really the way that people will communicate for hundreds of years. It probably won't take off because I'm not going to be able to get people to use it because there's already alternative chat apps. There's no way I'll be able to, basically break into that data network effect loop, right? So you should just give up, probably. But you shouldn't yet, because there's some good solutions here, right? And the reason that this happens, right, it kind of makes sense. The data is linked to the application, right? So Facebook, Twitter, or whatever, even smaller ones. It doesn't really matter what size, right? And the app owners, reasonably keep the data that they are producing on your behalf. Your data effluence, your sort of the things you're leaving behind as you use their website, which things you clicked on, what things you seem to hover over, or what you liked. And probably they're not actually doing anything super scary with your actual personal data. And a colleague of mine at one point recently, he said, I don't know, 5 years ago I just said, maybe this whole Facebook and privacy thing is not such a big deal. Maybe you just don't treat it like, it's public data, right? Don't put anything on those types of interfaces for the internet if you don't want it to possibly be used to sell you something later, right? And that's sort of a reasonable thing. It's like, look, don't put it on the internet. If you're a celebrity, don't put anything on the internet probably, but don't put things that you don't want used against you on the internet. But that's not quite far enough, right? Because actually it's like everything you do. So there are other ways to deal with that, but we'll talk about that a little bit. But this kind of, this relationship makes sense. Data is linked to the application because the application produces the data and wants to use it, and then they keep the data, right? And then it's like, okay, we're just going to get a bunch of data all in one spot. What could go wrong? And we've already decided, we've seen what can go wrong. And honestly, for the most part, like nothing really. For you and me and like individual people, not a lot goes wrong. The internet works really well most of the time. And it's interesting, you have conversations with people who are not as nerdy as me, perhaps, family members and things like that with real jobs. And you talk about the internet and how it works, and you're like, well, yeah, it's pretty cool. So like I take a photo on my phone, with Instagram or Textile. And you take that picture, and then it gets uploaded to some server somewhere, unless it's Textile, and then it goes straight to a phone. But anyway, I didn't want to explain that part because it's too complicated. So anyway, take a picture, it goes to a server somewhere, and then like fractions of seconds later, you get it on your phone. And you're explaining that to your mom, and she's like, that seems really stupid. Why would you need to take a photo here, send it to some server like on the other side of the country, and then send that to my phone when we're standing right next to each other? And you're like, yeah, that actually does seem pretty stupid. Why wouldn't we do that? And it turns out we can actually start to do that, and I'll talk a little bit more about that as we move along. But actually that works, because she does get the photo that I took, and I do get the photos that she took, and it works. So by and large, not a lot of terrible things go wrong. And that's okay, right? Because it's working pretty good. We've got this sort of nice system where perhaps someone over here is producing some data. It goes through an app that they're using on their device, their phone, their desktop, whatever. And that gets sent over to the nice robot server somewhere. And we've got this sort of client-server relationship that requires some trust, obviously. I have to trust that they're going to do what they say they're going to do with my data. But it's not really a balanced relationship because basically I have to trust them, but they don't really have to trust me at all. They're probably trusting that I'm not, I don't know, uploading weird stuff, but they can stop me anytime that they want. They can cut me off, they could deplatform me, whatever. So it's a sort of unbalanced system of trust. And so we kind of have a situation like this where this is a term our team uses, and I think it's a pretty common one, which is like you have app siloed data. Okay, so you have data that's tied to an app. And like, you know, at the outset, that's not necessarily a bad thing, right? It's just data that's specific for that app. The downside to that is it tends to provide a pretty limited view of a user, someone who's using something, right? Because it's only the data that that app has helped to produce for me, right? So like Twitter only knows about the stuff that I professionally tweet, or not professionally tweet, but tweet as a professional. And so that's not fully Carson, that's just sort of a persona that I provide. And then we have these network effects, right? So if only the app and the developers that work around that app have access, we have these network effects. I mean, that's why that's why Facebook owns like Facebook and Facebook Chat and WhatsApp and lots of things like that, because they benefit from data network effects, right? The more apps that they have using the same potential sources of data, the better. And of course, we got centralized control, and that's no good because we're at a decentralized web meetup. And this is what we think we deserve, right? Decentralized control, and I'll talk about what I really think that means in a little bit, because there's a technical answer and then there's a more like social answer. Then there's I changed this to network impacts instead of network effects. Not great, but when they animate like that, you need them to link across. So network effects becomes network impacts, and then we have user siloed data. Okay, and then we have a sort of broader view on people. So I'm going to talk about all of these different concepts in our sort of like what's the future maybe look like. But to give you a little context about these, okay, so user siloed data is instead of a single app producing some data and having sort of that app siloed data, user siloed data would be where me, the user, Me, the user, controls the data, and I can potentially allow apps to access my data. How many people are familiar with sort of like data science-y type terms like bring the analytics to the data, or bring your queries to your database, that sort of idea? So it's sort of like that, but for personal data, right? So instead of me saying like, hey app, I would like to use you, and you can produce some data on your back end, and then you only have access to it. Instead, hey app, I would like to use you, and you can access my contacts and my like diary feed, or like my Twitter feed. It wouldn't be Twitter obviously, but my feed of sort of random thoughts that I want to shout out to the whole world. You can have access to these types of data, and you can render it for me in an interesting way. And so you can start to get data that's controlled by the user, and I'll talk a bit more about how we do that more technically in a bit, and a potentially broader view of that user. So if I give the access to an app more information about me, they can actually better tailor the service or whatever that I am looking for. The important thing, though, is not to just like give the data away, but to provide access to the data. Okay? What that means is if I spin up an app tomorrow and I promise you, hey, look, if you give me access to your, I'll keep calling it a Twitter feed just so people know what I'm talking about. But like, if you give me access to your Twitter feed, I will render it in a very interesting way that like will make it easier for you to communicate with your followers or something like that. I don't know, right? I will provide a very good experience for you on top of that data. Now I have an app that works instantly from day one on people's data right away without having to deal with or trying to compete with other companies that have network effects already built in, right? So now suddenly we start to see a potentially very interesting platform for competition, which is now, instead of the best idea that happens to get awesome VC funding and then eventually gets bought up by some larger company wins, we have maybe the best idea might potentially win. Now, there's more competition, so you could easily lose all of your users right away, but I mean, that's your problem. So now we have network impacts. And then we have decentralized control, because if at any time the user decides, you know what, I don't want you to have access to my data, or you know what, this app is doing what you're doing but slightly better, or whatever, they can do that. They have that decentralized control. Suddenly, a bunch of issues like GDPR and like privacy data issues start to be less of a burden for smaller technology companies and more of a burden for data storage providers. And I'll talk a little bit about that as well, because someone's got to store this data somewhere. And the idea is that somewhere should be under the control of the user. But that's the landscape that I'm going to start to talk about. And so our team was like, oh, okay, well, that sounds awesome, but can we actually do that? Can we potentially separate our data from the apps, but still enjoy some services that you expect? And I think this is a really complicated. Well, the first question is easier to answer, which is like, well, yeah, technically you can do almost anything, so probably we can do that. But the second part is, can we still enjoy the services we expect? The answer, I think, there is yes. I mean, there's still software developers who can develop good software, so yes, we can get good services. The real question really is, can we still do it for free? Because so far I expect to be able to get an email for free and document collaborative tools for free and blah 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 blah. And that starts to be a more complicated question, which we can talk about a little bit more to the end, I think. But definitely, it's a harder thing to handle, and partly because we're changing the dynamic of that relationship. So it's a less one-sided trust relationship. So I mentioned earlier, I said I was going to talk about our original motivations and a little bit about what our more sort of current motivations are. So the original motivations were really about privacy. And I came from a geospatial or geographic data privacy kind of background, which is a whole sort of nugget in and of itself. And other members of our team came from different backgrounds in that sense. But that's what got us into it. But now what's really motivating us is this sort of interoperability issue, or interoperability opportunities, I think maybe is a better way to say it, which is the data network effects thing. Is if we have a bunch of apps that are potentially producing and sharing data, we can actually start to bootstrap interesting views on information faster. And I'll show you a silly example of that in a second. So yeah, we changed the dynamic. So now, potentially, and you'll notice I made the arrows in the opposite direction to really drive the point home. But an app's view is potentially now complete, right? Maybe not complete, but it does have a better view potentially on the users that it's interacting with. Now, maybe you don't want that, and in that case, you don't need it, right? Maybe I'm just going to make the most killer Twitter feed app ever, and all I want is your Twitter feed, right? And that's fine too. But maybe I want to provide some health insights for a user or something like that. But I don't want the responsibility of storing or dealing with their actual health data. Well, now I can provide a potential dashboard for a user on top of their health data, where their health data doesn't actually even need to leave their device, right? So now you can start to imagine some very interesting applications. And I'm going to get even crazier in a little bit and talk about some of the really powerful things that you could start to do when you start to think like this. But potentially what we have is apps actually could have access to more data and reduce network effects or more network opportunities, I guess is a nicer way to put that. And if you set it up right, so it's at sort of like the protocol level, then the relationship with your users can't change. That scary sort of curve can't happen, right? If I never have access to my users' data in the first place, I can't sell it behind their back. I can't, start to change the way I'm interacting with people. And so, how many people remember the bad old days of all these crazy skins on top of your Windows media player? Anyway, hopefully, I'm not too old. Put up your hand. Okay, good. So you can kind of imagine that this is where we would. I think design has come a long way since then, but the idea is you can imagine a different view on your data, right? This was just a different way of looking at a Windows Media Player type, view, and it's pretty static. It doesn't really change. But the idea is now you're talking about basically just views on data. Everything, all apps and things are just views on data that the user has control over. And so here's a fun animation maybe of what that sort of looks like. So that relationship still exists, right? So we still have users and maybe some reasonably centralized systems or federated systems if there's a bunch of them that sort of are mostly not controlled by a single entity. And that's what you kind of want in one of these frameworks, is you can have things that are sort of super nodes in the system that do useful things for users, make sure there's backups, make sure there's data storage. But if one of them disappears or a government shuts it down or a company goes bust, another one could pop up and still and sort of take over that particular job, right? So, the Fediverse and Mastodon is a good example of a federated, decentralized network. So you register with a server, but you can still communicate with all the other ones in the network. So that could still exist. And I don't know if you saw the animation, but this person down on the left was sharing data with the sort of federated server and then with their users more directly linked, or peer more directly linked with them. And so you can start to see these relationships happen. But one of the key things here is the little animation, the thing the packet that's getting sent looks a bit different than before. Because now the packets that are getting sent are encrypted under the control of the users. And I can talk about that sort of at a fairly technical level later if we want, but it's not exciting. But we can talk about that. But anyway, the idea is now, right, the users have keys that encrypt data. They can share those keys, and they're designed in such a way that you can share partial information so that it's possible to, say, follow someone's tweets but not actually be able to see the tweets. So maybe I want the server to keep backups of my tweets, but I don't want it to know what I'm saying. But I do want my followers to know what I'm saying, so I'll share the keys with them. Now, of course, none of this is happening, manually. You're not explicitly doing that. In an app, you would say, add a user or join a thread or, be the same sort of UX you experience normally. But now suddenly your phone is your key that you use to unlock this data or encrypt it, send it to a server, etc. And so you can actually do that user siloed data, right? So you can actually make sure that on device the data gets encrypted and it gets sent to a server in a nice encrypted format that the server can't do anything. And so I'm sort of saying you can do this, and it's a little pie in the sky, futurist type ideas, but actually is not entirely true. We can do a lot of this stuff already, and I'll show some examples of where we're doing this already. But there's other really exciting things here, and so I wanted to highlight some of them, which are when you start to think about user siloed data and encryption and sort of the privacy angle, not just from a privacy perspective, but from a what more can you do when apps are just views on data, the applications really start to blow up. And here's some cool examples. So if you can start to do things like allow apps to provide, like an example I used earlier is medical views on your data, medical dashboard. Okay. Well, if that app never actually gets access to my medical data, I can actually start to think about sharing data that I would never normally share, for obvious privacy reasons. And if you think about the amount of, say, medical research that never gets done for good reasons, because sharing private data is hard, right? Like I wouldn't want I certainly wouldn't want my insurance company to know I've got some very rare disease or something like that. Or I wouldn't want my employer to know, certain things about me, medical data. It's private information. A lot of people don't want to share it. But imagine the types of analysis you could do if you didn't share the data. If you didn't actually have to share the data, you could actually have the data processed either locally or in some encrypted format. And some of that is starting to happen already. How many people are familiar with homomorphic encryption? A few of you. Okay. This is like the most gross oversimplification of what that means. But basically, It means that you can start to do math on encrypted data in its encrypted form, and the result is encrypted data, which you could send back to the originator. But me doing the math, I don't know what the actual data is, right? And this sounds crazy, but it actually works, and you can do things like image manipulation where you don't actually know what the image looks like, right? So a server, I'm a Textile user, I take a photo and I submit the photo. If I submit it in a homomorphically encrypted way, I can actually process that data and you run a filter on it or resize it and transmit the encrypted data back. The user can decrypt it on their phone, and I never knew what that looked like. I maybe knew that it was a photo so that I knew what to do with it, but other than that, no access to the data. So now you start to realize that there's a lot of analytics and analysis and knowledge generation that can happen with reduced risk for the people who are producing that data. Now this is still research level stuff, but it's starting to happen. And a really cool project that if anyone's interested in this type of stuff you should look at is called Open Mind, like as in mining something. So mind, just spell mind. So not open mind, but open mind. And it's sort of like, yeah. One more time, Open Mind is what it's called. Anyway, really cool project, check it out. And they're starting to do some of this type of zero knowledge analysis. But anyway, that's the sort of point I want to drive home here is this is potentially starts to really open up a lot of new avenues for doing things when you don't have to trust a provider of some kind. Okay, so then here's my let's do this thing slide, right? So building a better home for humanities data. Realistically, I think the better home for humanities data is with us, under our control. And so, ideally what we want is a place where we can store our data. We do want services to provide, or we do want companies to provide services on top of data for us. I think we want that, and there's a lot that can be gained from that. But what we also want is the ability to permission that data and services to the people that we choose and know who those people are going to be. And maybe that permissioning doesn't have to be hyper explicit all the time, right? Like I don't want my phone to just be like, do you want to let this person use your data? Do you want to let this person? Oh, someone wants to see your tweet. You don't want to do that. That's too much. But to be able to do it in an intelligent way where it's like, look, I will provision this level of access to this bits of my data. I will provision this level of access to this bits of my data, presented in a useful sort of intuitive UX. And now it starts to become a lot more usable. And I just say useful, usable UX. Someone will figure it out. But actually, there are some very good design patterns that exist for access control, right? Be it at a sort of nitty-gritty database level, right up to sort of Facebook. Do I want to let my friends and blah 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 have access to this thing? Those UXs do exist. So we want that. And as a developer, I want to be able to capture network effects, right, to produce a new app or experience, for my users in a quickly and useful way. And as a user, I want to capture those network effects to actually potentially capture value from my own personal data. So one thing I didn't really mention is, but in theory, this world also allows people to monetize their data if they wanted to, right? And there are some examples already of people exploring the idea of monetizing medical data or monetizing, I don't know if anybody familiar with Brave, the Brave browser. This did a big release recently, actually. Totally check it out. But in theory, you can kind of get paid. I say paid because it's a right. Yeah. So you can get paid to browse, and basically you're paying for your attention, right? And there are lots of other types of examples like this where you can start to, when you have the control over things like that, you can start to think about actually, providing monetization strategies right down to the actual user. Now, ideally, there's a lot of design happening to keep the users from having to learn a whole slew of new interactions, right? One of the big things, how many people are sort of maybe crypto enthusiasts or have some cryptocurrency or have a crypto wallet or something like that? Because a lot of this stuff, sort of is related. Having keys to your data is very related to having a crypto key for cryptocurrency. And so far, that user experience is pretty terrible. If you have to manage your keys yourself, it's a real pain. And you have to be really careful with them and blah, blah, blah. And on the one hand, with cryptocurrency, you definitely have to be careful because it's literally like the key to the safe for your money. So you want to be careful with that. And then you start to think, oh, it's just app data. Except if we really believe this, then it's just as important or more important because now we're starting to think about storing really personal, potentially private information. So that user experience has to be done right. And what seems to be happening, and I'm going to say this, but I could definitely be wrong, is that a lot of people are starting to think that your mobile phone or whatever your mobile phone eventually ends up looking like is going to be your key management tool. My brother just got like a phone like this big. It's pretty cool, e-ink screen. But you can imagine that tiny little thing is essentially your key, and you start to be able to just provision access to apps, with your fingerprint on your phone or something like that. But that UX will have to be developed. So, that's I think what we want, or at least that's sort of what our team thinks is an ideal sort of situation. Here is, you got to write a white paper these days if you want people to take you seriously. So here's our white paper here. I come from an academic background, so it's nice to get to write a paper every now and then. And we did it in LaTeX, so it looks very fancy. But anyway, this is our paper, and it essentially lays out sort of protocol level, a lot of the technical details that we think need to be solved to start to realize this new green pasture. And so we literally called it that, a protocol and event-sourced database for decentralized user-siloed data. So the big focus there, right, is user-siloed data. The database piece there is, I'll talk about that a little bit, is to make it easier for people to wrap their heads around how you might interact with such a system. And the reason for that is because, remember earlier I said, oh yeah, we're going to get people with the privacy angle. People are they're going to be into it, right? And then it was like, nah, people don't really care. And also the sort of network effects thing, it's like, oh yeah, users will be onto that. And you're like, no, why would users care about that? They're just going to go to the thing that has their most friends that are also using it. But for any of this sort of shift to decentralized web technologies to happen, I think what we really need to focus on is developer buy-in, is to people to actually build stuff that is better than previous, better experiences, or do something more interestingly, or a new sort of experience before really you start to see a shift. And so that's kind of something our team is pretty focused on right now, is can you make it easier for developers to just start doing this, building apps in this way from the get-go. And if it's a huge hurdle to even just get started, then it's not going to happen, right? There are some really, really good developer tools out there for making a web app on top of, Google or Facebook or Amazon tooling. I mean, there's really good. People use Firebase. iCloud is a very good API. There are a lot of these, tools out there that make it really easy to make apps. So why wouldn't you keep doing that? So a big piece of this puzzle is, can you make it easier or the right move for a developer doing this? And so right now our team is focused on, a big chunk of our time on trying to do that. And so, if you want to learn more about some of the stuff we're doing from a technical level, we've got, a centralized GitHub repository that you could go to. And, I'm not expecting you to do that because, maybe you're not interested in that level of thing, but I put it up there. But we're also starting to build little tools and examples for developers of things that you can do using this type of model. Using a type of model where users have control of their data and they can revoke it at any time, they can shift it to any provider, that sort of thing. And so this is an example that one of my colleagues made called Boom. We were able to get boom.fyi as a domain name, so we did, obviously. And then we called it exploding links. And so what you could do here is you can have a user create some bit of data, a little snippet of text, or this is just a demo example. So, it's not going to be the next, killer app or something. But you can create little bits of data, and then they can encrypt it using a private key that only they have. They can put it online, available for people, and they can decide how many people can see it, or for how long people can access it, or a couple other parameters, which I can't remember off the top of my head. And what happens is you can go to this thing, and you can access the data, and it uses the Interplanetary File System, IPFS, in the background. And what happens is, the first person who accesses it will probably just pull it from our server running it somewhere. But once that person has access to it, potentially they're now sort of hosting that, and other people could access it directly from them in a peer-to-peer way. But once that timer runs out and explodes, the data is no longer accessible to anyone because the keys have been thrown away off the servers. So it's a demo, but it kind of illustrates the types of things that you can do, that you can revoke data. And this is something you couldn't really do with IPFS before Andrew released this, so it's kind of a nice, fun example. So I encourage you to play around with it if you like, and you can have the keys and sort of play around with it, delete the data, or make it only viewable one time, or things like that. I think by default it lasts 5 minutes or something like that, but I wouldn't put your banking data on there. It's a demo, but you can start to do things. You can do some really interesting things, like share a document that's only valid for a certain amount of time or something like that. Yes?
So does that centralized server for boom.fyi, that stores the keys?
Yes. Oh, this is a good question. But is a federated system. So we run one for the demo, but anyone can run boom FYI bot. I think we call them bots.
And then their links would have a different URL, or they?
Yeah, so you could have, each link would have a different URL, so it could be boom.fyi, or boom.fyi, boom.whatever, or whatever you want. Yeah. And you might even imagine a world where there's one for a specific topic or type of data or something like that. It'd be photos.fyi or something, and it could specialize in that. But that's the idea. Yeah, a very good question. Is the demo one is we're running that, but it's anybody can run it, and we've tried to make it so that's a big part of the mission, right? Is we try to make it pretty easy for anyone to run one. Now, your average internet curious person is not going to do it, but any developer or something like that could certainly do it. And then we also just recently released a bunch of tools to make running things like IPFS on the browser and on mobile and on desktop and things like that a lot easier for developers as well. And I'm pretty excited about a couple of these, just because they really do make spinning up web apps and things like that actually access decentralized web services quickly and easily. So these are sort of the things that we're doing to get us towards that vision that we're pretty excited about. And so now we're at the point where I can start to talk about the technical details and implementation details of Textile if we want. I'm getting some thumbs up, so we can do that. And then maybe I'll go sort of a little bit fast, so we have a little bit of time at the end for questions. But if you have to leave, I will not be offended. Okay. Okay, so now I have a sort of another title slide, a little bit about Textile at a technical level. And the whole point here is really that we want to drive user-controlled data for cross-application data on IPFS, right? So user-siloed data so that multiple apps access the same potential data source. And we always try to think, you always have to build the very low-level APIs and tools to get you there. But the idea is, we want to get us to some place where we're talking like iCloud, Firebase, if this, then that type APIs for developers. so that it's no longer just like, oh, you're making a web app from scratch. Well, you just use Firebase, and it gets to the point where it's like, oh, just use Textile. Or heck, if it's not Textile, someone else who is building something that is more user siloed. And a big piece of that paper that I mentioned, which you can download if you want, a big piece of that is really just presenting the protocol and sort of data format for user siloed data, and less so about necessarily the Textile reference implementation. So we've kind of separated the paper out into the protocol and then Textile, which is the sort of reference implementation that we are developing. So really, at the very least, we want people to use that sort of protocol data format to make it easier to share apps between different users. But obviously, if you use our thing, we would be happy about that too. But that's the idea. Okay, so we can look at a little bit of the technology behind some of this. So we kind of, at least for this talk, we break it down into kind of 4 main categories, which are how you secure the data to make that sort of user siloed experience possible. And then we talk about logs. This is going to get pretty technical, so we'll be ready. But anyway, so we've got like secure data, the logs that are used to store that data, the threads that are used to organize those logs, and then the sort of whole networking layer. Okay, and I will sort of gloss over some technical details. So if you want me to stop and talk about anything, happy to do it. I know everything. So we start with this thing here. Okay, so Textile runs on IPFS, Interplanetary File System. I decided to assume you all knew what that was. For a very, I could give a gross simplification of it, which is IPFS is essentially, the name is Interplanetary File System. Okay, so it comes from the idea of like potentially having a shared file system like across planets of the galaxy as we start to, it's pretty pie in the sky stuff. But the idea is it's basically a shared global file system where all the content files that are stored on that file system are accessed via their content, so what they are, rather than where they are. Okay? This differs from the current web, where we have a fully location-based addressing system. Okay? So the way it works is like if I want you to go to try out that boom.fyi thing, I say go to boom.fyi / cool thing, longer name, etc. / whatever. Right? So I've told you the location of the asset I would like you to go and fetch. And then you plug that into your browser, and your browser effectively is saying, hey, server that has this stuff, I want this thing. It's located here. Could you please send it back to me? The server says, cool, yep, here it is. And there you're on your merry way. In IPFS, instead of going by location, you say, hey, network, not any particular server, right? You say, hey, network, I want the thing that looks like this. And you give it a hash, like a cryptographic hash. And the network, which is a bunch of peers, a bunch of computers, goes, oh, cool, okay, let's figure out who has that right now. And they route you to the peer that currently has that data, or some of that data, and it starts to route it back to you. And this data could be split across many, many machines, like BitTorrent, some similar thing like that. And then it gets routed back to you. Okay, so in theory now, instead of going somewhere to get something, you just say, I want this thing, please send it back to me, and the network will do this work for you on behalf. This is like a terrible, terrible description, but it's enough to understand what's going on. Yes?
It's so much, I want what it looks like. It's just a query in a database that says, I want what this looks like, and if what it looks like is going to be bad.
Mm-hmm. So, yeah, that's like another similar gross simplification, but yes. Yeah. That's a good way to say it. So, you query things by their hash, and that hash is basically like you took that object and you ran a cryptographic hash over it, and assuming it's a good hash function, which it is, nothing else could possibly generate that hash except the thing that you originally generated the hash for. Okay, so if I have a file and it's called Carson's Great Ideas, okay, and there's only 2 things in there, and I hash that thing and I say IPFS, here it is, right? Here's my data, and I produce a hash for that, and I tell the network, by the way, network, my computer has this data. Here's the hash for it, and I add it to something called the decentralized hash table. Okay. Then I tell someone, hey, man, you got to check out my list. It's got 2 things in it, and it's really smart. Here's the hash for it. Okay. Then that person will, on their IPFS peer, will query the DHT for that hash. Now, the first time they query it, since I'm the one who produced that data, chances are I'm also the only one who is currently hosting that data. So when they ask the DHT or the network for the hash, they'll probably get routed to me, and they'll pull it to their computer. Okay? Now this is where the important thing for users comes in, but we have a question, so go.
When they go to you to try to get it from you, that means like if you happen to have your laptop shut, then the network's just like, oh, sorry, can't find it.
Yes. So for now, we'll assume my computer is still running. But I'll talk about that a little bit too. Okay, so then they get it, right? Now I tell someone else, hey, someone else, you should check out my list. And now they're going to ask the network for that list based on that hash. But now they could pull it from either me or the other person who happens to have it. They do not need to go back to the original location of the data. Okay, so now as popular content, say, because my list is very popular, it gets propagated throughout the network. Now people can start pulling data from wherever. Okay, because they have the content ID, not the location. All right. Now maybe they store the location too so that they know the next time they can go back and just get it straight from me, but maybe they don't. So that's how you solve that problem, is ideally you actually make sure that there are multiple peers that have some type of data. And so you start to get things like data pinning services. There's these guys called Pinata, which honestly is such a good name because storing data on IPFS for like permanently is called pinning it. Pinata, that's so good. Anyway, shout out to you, Matt. There you go. Matt's their CTO. Anyway, so they can do stuff like that, where they would pin it for you, and you can pay them to sort of keep it alive, or you just make sure that other people have copies of it. Okay, why that's awesome is because now I don't need to worry necessarily. I can move my data wherever I want, right? I could host it myself. I could ask someone else to host it for me, but the hash will never change, right? So now I don't have to go to dropbox.com/myfile and all the time to get my data. I could potentially shift it around anywhere, right? And I could potentially pay any number of providers, or one provider, or no providers, or whomever, to store my data, and the content hash for that data will not change, which means that I will always know how to fetch it. Now, obviously, I'm not going to write down a bunch of hashes to keep track of my data. So you'll see services and pinning services start to pop up that help you to manage where your content is and help you to route to content, et cetera, et cetera. But that's the principle. IPFS works on this principle of content addressing. And there are other systems that use content addressing. So if you don't like IPFS, you should check out one of those whose names I can't think of off the top of my head right now. But there are other systems. Okay. So why this is cool is because you can start to take things like raw data, you hash the data to create a content identifier. Then what you can do is, so now if you do that, it's just plain text data. There's no sort of encryption or anything like that. So instead what you could do is you could take your raw data, you could encrypt that raw data, you could hash the encrypted payload to get a content ID for the encrypted data, and then you could share that with people. So now they know how to extract the encrypted data, or they know how to get the encrypted data, but they don't necessarily know what's in it, right? So then you can start to see, well, providers can actually provide storage for you without even knowing what it is that they're storing, as long as you maintain the keys. Now, if you want them to have access to the data, you could give them the key as well. So this sounds really awesome. You can do things like use public key cryptography or public key encryption. So basically, I would announce, I'd say, this is my public key, okay? And you can, maybe you're a provider, or I can encrypt data with the public key. And then I can publish that data. And then people could store it for me. And then only, because I'm the only one who has the private key, only I can decrypt it. Similarly, I could, and this is what we do, or sort of what we do at Textile, is I can encrypt the data itself with a one-time special key. And then I can get the CID, the content ID of that. Then I could use my public key to, this is an example of what you could do. Then I could encrypt the content ID, and I could actually then add that to IPFS and share that. And there's a lot of different ways that you can layer that encryption depending on how much access you want to give somebody. If you want them to store the data but not see what it is, there's one way to do that. If you don't even want them to know the actual final content ID of the data at all, you can also encrypt a layer higher. And so there are a lot of different strategies that you can use. It gets a little more complicated when you want to start sharing data with specific parties. And there are a bunch of cryptographic techniques for doing this, Diffie-Hellman key exchange, and a bunch of really fancy stuff that I'm not going to talk about here because A, if I get it wrong, someone on the internet will tell me that I got it wrong. And it's very complicated, so you should never do all of this crypto stuff yourself. You should use some standard libraries for doing it. And B, because it's not that, I mean, it's exciting like at a math level, but you know, just if you use the libraries, there's a lot. There's been some amazing advances in cryptography libraries in the last sort of 5 to 10 years that have taken a lot of the guesswork out of it. And so if you just use those ones, they will do it correctly for you, and there's a little less potential for you to mess up, because it's pretty easy to mess up by, you know, sharing the keys with the wrong people or something like that. Anyway, it starts to get pretty complicated when you want to start to share data with multiple people, okay? Especially if you don't know who those multiple people are going to be later on down the line, okay? So for instance, if I wanted to have, say, some form of Twitter where, or another example is like Instagram chat kind of thing, where, you know, I want to be able to chat with like family members about certain photos, but I only want those family members to have access. But then, you know, we left out Aunt Susan. Oh shoot, we forgot to, and we want to add her to the group. And in certain situations, if you wanted to add her to the group and you didn't add her from the beginning, you would have to derive a whole new set of keys and blah, 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 and it's going to be a huge hassle. So then just Aunt, what did I say her name was? Susan never gets to see these nice pictures of little baby Ellen, okay? And it's too bad, just because it was a hassle. So it starts to break down a little bit. You know, if you're working with a group of people, the group size changes, it starts to get complicated. So you have to kind of come up with a way to deal with that. Yeah, those are the situations where it breaks down. So that's where Textile logs starts to come into the picture, okay? Which is we've essentially developed a protocol level, or a protocol for handling encrypted blobs of data on a related topic that you can start to use to build up your Instagram chat example. Okay? In a way that if you add people or remove people from a group, it's not going to mess things up for everybody. Okay? So this is where it gets pretty technical, but here we go. So Textile logs are, how many people are familiar with Git and GitHub for managing your code or something like that? Okay, cool, most people. So in Git, every time you make a change and you submit those changes, it creates a diff. And that new commit that you make to, say, your branch of a repository or something like that, it references the previous commit, and so on and so forth. And you get this very long chain of changes. And it's a really great idea because that means that I can always trace back. I can figure out the history of a particular repository. All I need is the sort of head, or any head, actually, any point along that chain. If I get there and I know it's actually a hash that encodes the commit. It's that long random string of numbers that's the commit. That's a cryptographic hash. As long as I have that, I can work back throughout the whole history of that Git repository. And that's pretty awesome because it means that I get this provenance. But it also means that we get a basically log of the history of that, in that case, that topic, right? That Git repo. Now with code, it's text-based. It's a lot easier to sort of wrap your head around that. But you can do the same thing with any arbitrary bits of data. And every time you add a new bit of data to a log, it gets a hash, and it references the previous hash. And you get a hash tree so that if I know at any point along that log, I know the hash, I can trace that whole history back. Now, if you do it right, you can trace the whole history back even if you don't actually have access to the encrypted data. So I can get the links between the data without actually necessarily knowing what the data itself is. This is really important because that means if something becomes unavailable on the network, but I still have the links between them, I can still work back in time to the sort of beginning and maybe eventually fill in the missing pieces as they become available or something like that. So if someone turns off their laptop or closes their laptop and they were for some reason the only one that had that, when they turn it back on again, I could still get that data, potentially. So that's a pretty useful thing to have. Again, similar to Git or something called Secure Scuttlebutt or a DAT protocol or an event store, which uses a sort of read-ahead log to store things. Similar to a lot of existing technologies, a Textile log is for one single writer. Okay, and that's like your phone would be a writer, single writer log. And so I just add stuff to my log, new Twitter post, new profile update, blah, 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 whatever. It gets added to my log. And I can only add things, which means that if I want to delete something, I have to add an item that deletes a previous item. Okay, so you can only add stuff. It just makes it easier to manage things. And then I can essentially notify anyone else who's interested in the topic that I happen to be contributing to. Hey, I've made an update. You can go and fetch it. And that's where this multi-addressed thing comes in. So I basically have a bunch of addresses that reference items in my log, and people can pull on it. It's very similar to Git. Again, own Git. I've cloned it on my local computer. I'm making some changes, and then I make a commit, and then I basically submit a pull request to a central repository. In this case, I would basically make a pull request to directly to my peers. I would say, hey, I have some data. You might want to pull it. And then they can pull it, and they would basically combine it in their thread, which I'll get to in a second. So the really cool thing here is a log is the sort of like main thing that's important. And we use multiple layers of encryption so that I can encrypt the actual data itself. I can then do it one layer above. And what I can do actually is I can take that encrypted data, which I add to IPFS, and then I can encrypt the CID that you need to access that, along with the keys to open it. And I put that in a package, and I encrypt that, and I put another layer of encryption over on top of that. So now what I can do is some really cool things. Like I can say, hey, you can follow my log, but you can't ever know what's in it. You can just know that one thing came after another. So that's one level of encryption. I could also say, hey, you can have access to my log. And I guess you could do this. You can also contribute to it. But no, yeah, you could definitely do this. You can contribute to it or to a related thread, but I don't know if that's good enough, right? So then what you do is you give them the next layer down. Okay, you can say you can share information with me like in this thread. So you give them that key. And now they can follow you. Then they can pull that first layer apart. And they can access the keys to then access the data underneath. But if I didn't give you those different layers of access, you won't be able to see it. Or what you would see if you somehow got access to the data is just gobbledygook random encrypted bytes. Okay, so this is what a log is. It's a series of updates, just like a sort of a Git hash tree. Each update contains metadata and a symmetric key for accessing the actual encrypted blob of data. Then you encrypt the next layer up with a read key. So that's the key that lets you access the data to read it. And then all of this other stuff, which we call a header, the content address, the signature, etc., is encrypted by an additional key, the follow key. So if you only have the follow key, you can only just follow the updates but not do anything with them. If you have the read key, you can actually get access to the data. Logs can only be updated by one person. Okay, so the way we get around sort of collaborative workflows and things like that is where threads comes in, and I'll talk about that in a second. So logs have multiple providers, and you can pull updates from other people's logs. Okay, and you can only add things to them. You can't take things away. This is very similar to like standard database type stuff. Okay, here's an animation, but it's not that important. Oh yeah, now I mentioned earlier what happens if someone goes offline. So that's where your follower key would come in. You could actually potentially pay the network or some peer or someone to follow your posts but not actually have access to them. So you don't need to trust them, but they're backing you up if you want. But if that doesn't happen, if you don't want to do that, you can also just wait until you come back online and your users can pull that data directly from you. Your followers could potentially pull that directly from you if you wanted to do that as well. Depends on how paranoid you are, basically. Okay, yes?
Maybe it's like premature optimization, but like it seems like a lot of data for perhaps a relatively simple thing that you're updating every once in a while. It's generating like a symmetric key and all this metadata for each iteration.
Yep, that's a good point. Okay, so one is, yep, that's true. If you didn't want, like if you didn't care about the encryption level, then you wouldn't do, you can just not do a lot of those different layers of encryption. So that's one way, is like that's a lot less data if you don't need to share the keys. Two is actually it's not like the keys themselves are not that big. And we use industry standards sort of sizes, but it actually is not a ton of network traffic. The other nice thing about IPFS and the content addressing is you do get data deduplication. So if I've got multiple people in a thread, which I'll talk about threads in a second, that are accessing the same data, and we've got it on multiple computers, I can pull it from wherever. Even if I'm like in the same room as someone, I can potentially pull it over a peer-to-peer network. So there's a lot less actual duplication of the data that's happening. But it's a valid thing. If you don't need that level of encryption, then you probably shouldn't use it. And if you do, then you have to be okay with more data per bit of data that you're sharing. But yeah, that's a valid concern. Yeah, okay, so threads.
Oh, sorry, and then I had one other question. You had said that like to be able to delete something, you'd have to append to it to delete it, just like with Git. Like, what if you really needed to delete something from the history, like to purge it from the history with the same challenge that you have with Git? Like, is that even possible with this?
Okay, so deleting things on IPFS or potentially any content addressed system is it's a little tricky, but it's actually not that crazy, right? So if I generate a hash, that hash is sort of like the permanent hash for that bit of data, okay? And if I add it and people retrieve that, right, there's nothing I can really do forcefully to take that away from them anymore, right? They have it. In theory, you could force push. We haven't built the mechanism to do this, but in theory, you could build a system in which you could force push a removal, or you could change your log. And the best that you could do is say, hey, could you please delete that data that I accidentally uploaded? And that's the best you can do, right? It's just like if you've already sent an email, and sending an email like, please don't read that email I just accidentally sent, you can do that, right? And if the peers in your network are obeying the protocol, then their clients should do what you asked, right? But like anything on the internet, once it's there, you have to assume, once it's out of your control, you do have to assume that it's possible that it's there. So the answer to that question is like a lot of the same Web 2 tools exist to undo stuff, but you pretty much just have to assume that it's possible that it won't happen. I think that's the best answer.